Hi everyone. So I'm Vincent Dampuré. I'm product manager crash for HyperWorks. So responsible for the LS-DYNA radio spam crash interface and crash and safety tools in HyperWorks. And for today's presentation, I will present you the changes that we have done in the 2023 release for those interfaces. So the agenda for today, we'll start with the radios interface, then the LS-DYNA interface, spam crash interface, and go through the crash and safety tool updates at the end. During the presentation, I may maybe repeat myself because some of the developments have been made common to the different interfaces, so I may present a little bit more in details at the beginning and go through the others interfaces points a bit quicker than. Before starting over the interfaces, just let me remind you the support of HyperWorks for the explicit solvers. So we have all those supported domains of application, so these explicit solvers are not just for crash and safety, they're also applied for many other domains of application that are also supported in HyperWorks. And regarding the radios interface for the 2023 release, we have implemented the latest radios version, radios interface 2023. So that's the latest version of radios is supported in HyperWorks. Maybe not with all the keywords updates, but at least the import export of radios 2023 models is allowed. We have also improved the support of the radio submodels with the support of nested submodels, which was one of the key functionality missing in HyperWorks interface. And we have also added multiple new keywords and updated also keywords in regards to the latest versions 2022.3 and 2023. I will not go through the details of all of those changes now. So if you have, if you want to have more information of those changes, I would like to refer you to the release notes of the version. But one of the major changes in this release for, I would say, all the interfaces, and of course for the explicit solvers interfaces as well, it's about the panels, the final panels removal, and one of the biggest, which was pending, is the removal of the 1D element panels. So this one has been now fully removed, and you have now access to the 1D ribbon in HyperWorks with access to the different icons for the creation of the different 1D elements, so springs, rivets, SPH, truss, beam, and plots for the HM plot element. Similarly, with the inside the model ribbons with access to rigids like airbody, RB2, airlink, and RB3s, as well as the joints. Whereas here for the joints, it's actually a completely new tool that has been implemented, not just an equivalent tool as in the panel. So here the new joint tool allows you to create and automate. It automates actually the complete creation of the joints for radios. So depending on the selected joint type, so it creates the corresponding spring elements with the corresponding property, K-joint2, and the links to the selected rigid bodies. So just as a to show you here, for example, the typical creation of a rigid body, it's as quick as in the panel, it's automated. So you have the auto creation process, which creates the rigid as soon as the selection of the dependent nodes is done. And of course, everything is assigned properly to the element. As I mentioned, the joints creation is completely automated now. So you just need to select a rigid A, rigid B. Of course, first the joint type that you want to create, and select the nodes which are mandatory for the creation of this type of joint. And at the end, the joint will be automatically created with the elements, the spring elements, the rigid connection with a merge air body, and the corresponding property prop K joint 2. So just a remark on the behavior of the controllers. Some important aspects that have been put in those controllers. The selector auto moves. So basically, once you validate one selection, it automatically moves to the next selector so that you have a smooth workflow by selecting the entities requested for the creation of the elements, and at the end you have the possibility to auto create the elements when the mandatory selections are made. So this is an option which is per default activated, which replicates exactly what was happening in the panels before. One difference with the panels specific to the beam creation, the beam orientation node is now created in the session and assigned to the element, and not more created during the export. An important work that we have made also across all the profiles is the cleanup of the 1D element entity editor to make them solver accurate, which was not the case till now. We had many attributes in those entity editor which were not necessarily solver relevant or redundant. So this is just an example here for the beam element, but it has impacted, I would say, most of the 1D elements in those solver interfaces. Another option which has been added in the rigid entity editor for the independent node, which was one option in the panels, which is now available directly in the entity editor context menu option of the independent node, is the recalculate node position option. So here a quick demonstration what it means. So basically here you have rigid bodies with the independent nodes at a certain position. You want to reposition them at the geometrical center of the dependent nodes, and it is done in one shot, and also working for as you have seen, for multiple selections in one shot. Another improvement is made in the mass measurement context. This is also a change that have been made across the profiles, across the interfaces. So these changes, these changes affects the addition of the COG and MY options, which were previously added in the mass summary tool. So now here in the mass measurement context, the first is the choice of the axis of the coordinate system in which the COG and the MY values will be calculated. So it can be, per default, it is the global system, but you can have a local system selection. The MY center also can be changed to system center. Per default, it's at the center of gravity. And finally, the consideration of the lump mass for the COG and MY calculation, which is per default off, as it is done for the solver. And you can turn it on if you want to have the center, the lump mass considered in the COG and MY calculation. One remark which is not here on the slide is this last option, consider lump mass, it's only valid for radius and the Steiner profile. So on the same topic, inside the mass summary tool, there were a couple of changes made here in the radius interface. The first is the addition of the option to consider the time step mass. So the solver numerical time step mass, which is due to the imposed numerical time step. Oh, come on. So here the user can give the time step value which is imposed for his model, and HyperWorks will automatically calculate the the numerical added mass for each part, and at the end of for the full model, you have the total time step mass and the time step mass ratio, which is exposed in the total values. Sorry. Just a remark for radius. The calculated time step is in that case the elemental time step and not the nodal time step, right? Important to notice. And another improvement, which was requested as well for a long time, is the export of the table data for the mass, COG, and MOI values, considering the assembly levels. The assemblies are now exported, and as you can see here in Excel, you have the complete command. Sorry, and you have the assembly tree, and also the total values are also added in the exported data. And as well, once you activate the export from the blanks space, it exports the full table data, which was not working before. So moving forward to the LS-DYNA interface. So here as well, we have made, of course, multiple and different changes in keyword supports and keyword updates for with regards to the R30.1 solver version. So here as well, please refer to the release notes to have more details. We have made keyword migration to a new entity. So the initial stress option, so initial stress shell and solid and T-shell and beam, as well as initial strain for the same elements, have been now migrated to the new initial state entity. So previously, if you remember, these values or those keywords were actually directly integrated inside the element cards, and which was actually a big issue because with this support inside the element cards, we always lost the include in which the initial stress or initial strain data were written. They were automatically moved to the elements include files. So this is now, with this migration, one of the biggest issue with this handling of initial state values inside includes now fixed. Just notice that these keywords are for now only supported for import-export, so there is no creation in the session for initial state entity. And further enhancements are already ongoing, like the performance improvements in terms of import-export for initial state data, which are in most of the cases big data. So here there are some huge improvements to be made in terms of performances, which are actually now ongoing, and same for the editing and the plotting features on those initial states to see the values plotted and distributed on the elements. This is also something that is planned and will come very soon. So similarly to what I have presented in Radius, I will here maybe go a little bit quicker. So the same has been done for the migration of the 1D panel for LS-DYNA, of course. So here you have access to the rated icons in the 1D ribbon with the creation of springs, bonds for the constraint rivets, SPH elements, seatbelt element, beams, and plots. So exactly what was doable in the panel is now doable from the ribbon. And of course, rigids and RB3s are accessible also here from the ribbon, so the new controllers. And the joint, which the joint controller, if I remember, was already implemented in the version 2022.2 or .3. Sorry, I don't remember exactly, but the tool was already there. It's now just accessible directly from the ribbon within with the icon that you can see here. And in terms of behaviors, just to recall that it works exactly as I have exposed previously for Radius. 1D element entity cleanup as well. So here an example for the beam element. So we have made all those elements entity editor solver accurate, and again, once the elements are created, if you want to update any of those elements, the update goes now only through the entity editor. So that's the reason why we made this this cleanup to be accurate with the solver. And the rigid entity, rigid element with the recalculate option for the independent node is also available, of course, here. For SDyna, we have also added new options for the contact penetration check. A new feature which now allows to read the solver output files, which is the message file, which contains the contact. I'm sorry for that. Which contains the contact penetration warning messages. So you can now read this data, this file directly in HyperWorks. It will read the content of this file and populate the penetrations, the contact penetrations inside the penetration browser, which gives you then access to those information in the browser where you can directly use the tool to fix those penetrations. So this is important. This is an important enhancement because with this feature, we exactly report the penetration that the solver has reported. For now, it is just a reader mechanism. We think also to enhance this process to directly, to directly write out the model and start the solver also directly from HyperWorks to generate the message file and read it automatically. So the complete workflow for checking with the solver would be also implemented. For now, it's just reading the output file. So it means that the user, needs to start the model by himself, get the output file, and refer this file then in HyperWorks. So here an example, if I select the folder where the output file is located and check it, those are the penetrations which are then read, and you have access to them. You can then use the automatic depenetration tool to fix all those penetrations automatically. Mass measurement context enhancement, that's the same what I have presented just before, so I will pass this slide. Mass summary tool, time step consideration, that's the same as what I have exposed for radios. Just here, one difference is that it is calculating the elemental time step, which is exactly what LSDyna does. So what you see here in the GUI as a result is matching the solver. And in terms of table data export here, the same. We have improved the export with within the tool to have the assembly levels and the total values at the end of the exported file. PAM crash interface as well has been modified and enhanced on different points. So the first one is the property entity, which is further cleaned up with the migration of the enlave and groupmo keywords to the material behaviors entity, and at the same time, in terms of consistency within with other solver profiles and inside the PAM crash interface as well, to have we have combined all the failure keywords to the single entity material behaviors under the config failure. So you have actually here two migrations, or let's say three migration, the enlave keyword, the groupmo keyword, and all the keywords which were already supported inside the failure entity are now migrated to the material behaviors behind this failure config. Similarly to the other profiles, the 1D panel is of course completely removed. You have now access here to all the 1D elements within the 1D ribbon for the for the spring, for the masses, the gap, the SPH elements, bars and E-link and beams. So everything is covered within this ribbon. And of course, similarly for like other profiles, the rigids are also covered within the rigid controller. So for the rigid body, air body, Linko, MTOCO, and so on. And same for the RB3s with the OTMCO. And as for the radius profile, in the PAM crash profile, we have added a completely new joint creation tool, which does, as for radius, a complete joint creation process, which is fully automated with the creation of the spring element, the property assignment, and the correct property card assigned to the element depending on the joint type selected. So that's exactly the same, more or less the same process as what I have exposed just before for the radius profile. Behavior of the controllers, same as for the others. And here as well, 1D element cleanup has been done. And as you can see, I guess for the PAM crash interface, it was more obvious than for the others. So here, for example, for the beam element, you see how many attributes were shown in the entity editor, which were actually not solver accurate or fully redundant with others. So after cleaning it up, you see now that you have a much concise and solver accurate entity editor for the beam element. Yes, the mass measurement context enhancement is done as well for PAM crash, and the mass summary tool as well enhanced as for the other profiles as well. So this was, I would say, the main changes in the explicit solver profile that we have made for this 2023 release, in which now, as you can see, we have fully removed all the old panels and migrated everything to new tools, new controllers to do the job that was previously doable from the panels. Let's move now to the safety solutions overview, just to recall everyone what we support today in the crash and safety applications and occupant safety applications. So we have, I would say, all the tools for the occupant safety application for which are requested today, like the dummy positioning, the seat mechanism, the pre-simulation tools to deform the seat and the dummy, the creation of the seat belts, and in terms of impact analysis, we have pedestrian impact tool for pre and post, IP impact tool covered for pre and post, and the barrier positioning automation tool, which position the barrier depending on the selected load case. And I would like also to recall everyone that some months ago, the Altair Safety Report Manager, so-called ASRM, has been made available inside the Altair marketplace, which is an extension that you can directly download and plug into HyperWorks. So this automates most of the crash and safety regulations, post-processing process, creating at the end PowerPoints or HTML reports, and you have different modules that you can use inside this automated report manager for structural and component analysis, structural and occupant analysis. So today we have all the regulations which are available on the market, which are covered by the tool for the different load cases for frontal, side, and rear, and you see the different global regulations which are supported today. These are the few examples of results that you can get from the results of the analysis, and which are then automatically reports put inside the report. And you can also do multiple design iterations, overlays to compare different runs. So everything is automated in this tool, and I encourage anybody that deals with crash analysis to try this on the post-processing, because it's really interesting. So in terms of crash and safety tools enhancements, I would say for the 2023 release cycle, is mainly done on the human body models positioning. So we have worked together with different teams members on the creation of positioning files for the following human body models, which are today available on the market. So you have the LS-DYNA GHBMC M50O version 6.0, the LS-DYNA SUMS AM05 version 6.1, the LS-DYNA SUMS AM50 version 6.1, and the STUMS AM95 version 6.1 as well. So for those models, we have already created positioning file that allows to position those dummy models or human body models inside HyperWorks. We are continuing to make some improvements in those files, but the main functionalities are there. And we continue, of course, to work on other human body models, because those are just a handful of what is actually available on the market today. So there are still work ongoing, but you can see here in this recording for this GHBMC model, which is a model that you can get from Elements. You see that you can access the different joints like it works for any standard crash dummy, and position your human body model. And from this, from the dummy positioning tool, you will have access to all the actual functionalities which are already implemented. So that, for example, the pre-simulation, which in that case must be performed, because the human body model is in that case, once you position it, the mesh of the dummy model is, I will not say optimal, and you may have also intersections and penetrations with other parts. So you will have the same functionalities as for the standard crash dummies, the ability to export a pre-simulation that you will run then with the solver to get the correct positioning of the HBM. Okay, so this was, I would say, the overviews on the different enhancement that we have made for this release. Just one remark on the positioning files for the human body models. In fact, these positioning files are not tied to the version 2023. So if any is requesting a positioning file for one of those dummies and uses a version which is a previous, an older version, but having the dummy positioning tool, it will work as well. So yeah, this was just a remark on this topic. So thank you, everyone. If you have any further questions, please let me know. Thank you.